In 1969, the locomotive shops of Schenectady, New York were running out of time. For generations, ALCO had filled these buildings with machines that shook the ground, including steam legends like Union Pacific's Big Boy. But now, the factory that once helped define American railroading was approaching the end of American locomotive production. The strange part is, ALCO did not miss the diesel revolution. It helped start it. So how did a company with the history, the engineers, and the early diesel experience lose the locomotive war to EMD and General Electric? The answer begins with a giant that saw the future early, then watched that future leave without it. ALCO began as a consolidation on a huge scale. In 1901, several established locomotive builders were brought together under one name, the American Locomotive Company. Its plants stretched across the country, but Schenectady, New York became the symbolic heart of the operation. What ALCO inherited was not just factory space, it inherited decades of patterns, tooling, foundry knowledge, and railroad relationships. This was a company built around heavy metal, boilers, cast steel frames, massive cylinders, complicated valve gear, and the custom engineering needed when a railroad wanted something stronger than anything it already owned. In the steam era, that mattered. Railroads did not buy locomotives the way someone buys a standard truck. They came with grades, curves, axle limits, coal quality, water stops, freight tonnage, passenger schedules, and operating habits. ALCO could take those requirements and turn them into machines built for specific jobs. That reputation put ALCO at the center of some of North America's most demanding motive power. If a railroad needed mountain hauling muscle, fast passenger power, or experimental giants that pushed the limits of steam design, ALCO was one of the builders it trusted. The company's strength was complexity. Its engineers and craftsmen could solve problems with more steel, larger boilers, stronger castings, and specialized designs. In steam, that was often exactly what railroads needed. But the diesel age would reward a different kind of builder. Not the one best at custom giants, but the one best at standardized production, reliable electrical systems, and nationwide service support. ALCO's empire had been built for one war, and the next one would be fought by different rules. Steam locomotives kept the old business local, physical, and labor-intensive. A railroad needed boiler washouts, firebox inspections, tube work, bearing attention, valve adjustments, and shop crews who knew that railroads' particular machines. Even a successful design could become a small family of variations once different railroads asked for different tenders, drivers, appliances, fuels, and clearances. Diesels changed the purchase from a custom machine into an operating system. The prime mover mattered, but so did the generator, traction motors, control gear, cooling system, spare parts catalogue, field service network, and training program. That question favoured standardization. If one unit failed, a crew needed interchangeable parts, clear manuals, and technicians who could diagnose electrical faults quickly. If traffic grew, a railroad wanted more units that behaved like the last units it bought. If financing was tight, the builder needed payment plans, lease structures, warranties, and confidence that the machine would earn money without disappearing into the shop. This was a major shift in power. In steam, a builder could win by engineering a brilliant locomotive for a specific assignment. In diesel, the winner had to manufacture at volume, control quality, support customers after the sale, and make the product simple enough to repeat thousands of times. ALCO understood diesels early, and it was not a bystander. But being early was not the same as mastering the new rules. Another company was about to turn the locomotive into a standardized industrial product, and that would change the war completely. ALCO was already inside the diesel story before most American railroads were ready to believe in it. In the mid-1920s, ALCO joined a three-company partnership with General Electric and Ingersoll Rand. ALCO supplied the locomotive frame, running gear, cab, and mechanical structure. General Electric supplied the generators, traction motors, and controls. Ingersoll Rand supplied the diesel engine. Together, they were trying to solve the central problem of early diesel power, how to turn a relatively new internal combustion engine into a practical railroad machine. The proof arrived in 1925 when Central Railroad of New Jersey No. 1000 entered service. It was a boxy, modest-looking switcher, but historically it was enormous, one of North America's first production diesel-electric locomotives. It did not need to look heroic. Its job was to work reliably in yards, start and stop often, and prove that diesel-electric drive could survive daily railroad use. That mattered because switching was one of the best places for diesel to win first. Steam switchers wasted fuel while sitting, filled yards with smoke, and needed constant attention. A diesel switcher could be started, used, shut down and maintained with fewer of the rituals that surrounded steam. ALCO built a strong reputation there. Its early HH switchers, then the S-series and related yard locomotives, became familiar machines in industrial districts, terminals and freight yards. They were not glamorous, but they gave railroad managers a practical reason to trust diesel power before mainline diesels fully took over. Then ALCO helped shape the next form of the diesel locomotive, the road switcher. The RS1 combined visibility, low-speed pulling ability, and enough flexibility to work freight, branch lines, yards, and local service. Its basic idea became one of the most important locomotive layouts in North America. So ALCO was not chasing the future from the back of the pack. It helped invent the machinery, prove the concept, and define the shape that diesel power would take. The tragedy is that proving the future existed was not the same as owning it. Then came the machine that changed the race. In 1939, EMD unveiled the FT freight diesel. On paper, it was a locomotive. In practice, it was a complete system for replacing steam on mainline freight trains. Its car body units could be coupled together into powerful sets, operated by one crew, maintained with standardized parts, and sold as a package that railroads could understand. At the center was EMD's 567 engine. It was not simply powerful, it was built around repeatability. The same basic engine family could be manufactured in volume, serviced across a growing fleet, and refined through constant production experience. General Motors gave EMD the industrial muscle to turn that design into a product line, not just a promising experiment. Railroads noticed. The FT demonstrator toured the country hauling real freight, proving that diesels could do more than switch yards or handle special passenger trains. They could climb grades, run long distances, and avoid the water stops, ash handling, and roundhouse routines that made steam expensive to operate. Just listen to the kind of sound that was beginning to replace the exhaust beat of steam. World War II made that opening even more valuable. Wartime rules limited what builders could produce, and the government controlled materials, priorities, and locomotive orders. EMD, already positioned with a freight diesel ready to go, kept building and improving its design while many competitors were restricted or pulled toward other war production. ALCO was not idle. It built locomotives, engines, tanks, marine equipment, and other machinery for the war effort. But its attention was divided, and its road freight diesel program did not get the same clean runway that EMD's FT enjoyed. By the time the war ended, the battlefield had changed. EMD had experience, customers, parts commonality, and a proven freight diesel identity. ALCO came back swinging with new road locomotives of its own, but inside those machines was a weakness that would turn ambition into trouble. ALCO's post-war answer looked exactly like the kind of locomotive railroads wanted to buy. The FA freight units and PA passenger units had the presence of machines built for a new age. The FA brought the enclosed cab unit style to freight service with a broad nose, clean sides, and enough horsepower to work in multi-unit sets. The PA went even further. With its long sweeping car body and graceful front end, it became one of the most admired passenger diesels ever built. On publicity photos, they were hard to resist. A PA in fresh paint at the head of a named passenger train looked modern, fast, and expensive in the best possible way. An FA set on a freight drag looked like ALCO had finally met EMD on its own ground. But the critical part was not the sheet metal, it was the engine underneath. ALCO built these locomotives around the 244 diesel engine, and the important point is that the 244 was not a failure simply because it was a four-stroke engine. Four-stroke diesels could be strong, efficient and durable. The problem was timing. ALCO pushed the 244 into road service before all of its long-term weaknesses had been worked out. That meant customers were not just testing a new locomotive, they were discovering its problems while trying to run daily railroad service. The complaints that followed damaged ALCO at the worst possible level. Confidence. Railroads dealt with serious component failures, turbocharger trouble, and engine durability issues that could take units out of service when they were supposed to be replacing steam. A diesel that saved money in theory became a headache if it spent too much time waiting for repairs. This happened just as railroads were making once-in-a-generation decisions. They were not buying a few experimental machines anymore. They were choosing diesel suppliers, maintenance systems, parts inventories, and long-term fleet standards. So the FA and PA gave ALCO visibility, but the 244 gave it a reputation problem. And in the diesel race, reputation could become almost as important as horsepower. For a railroad president, the locomotive was only the visible part of the purchase. Behind every diesel order came shelves of spare parts, new shop tools, mechanic training, inspection schedules, warranty claims, and the expectation that the builder would still be there with answers years later. That is where EMD gained its most valuable advantage. Its locomotives developed a reputation for being predictable. Units shared parts, maintenance practices became familiar. A road foreman or shop superintendent could look at an EMD fleet and see standardization instead of surprises. ALCO still had strengths. Its locomotives could be muscular, attractive and impressive on the head end. Plenty of railroaders liked the way they loaded, sounded and pulled. But executives were not buying charisma, they were buying availability. A locomotive that was beautiful in publicity photos did not earn money if it was sitting dead at the shop. The damage from the 244 was not limited to a failed part or an angry customer. It made future ALCO proposals feel like a risk inside the boardroom. If a railroad had already stocked parts, trained crews and reorganized shops around another builder, switching back required more than liking a new model. It required trust, and ALCO was trying to win that trust while the market was hardening around fleet logic. The big railroads wanted fewer variations, simpler inventories, and suppliers that could support hundreds of units across thousands of miles. Even when ALCO improved its products, the question had changed. And then the situation became even more dangerous, because one company that had once helped ALCO sell diesels was about to become a direct competitor. The company was General Electric. For years, GE had not been an enemy of ALCO. It had been one of ALCO's most important partners. In a diesel-electric locomotive, the diesel engine did not turn the wheels directly. It drove a generator, and that electricity powered traction motors on the axles. That meant the electrical system was not a side detail. It was the heart of how the machine actually moved a train. ALCO supplied the locomotive design and the diesel engine. GE supplied major electrical equipment, generators, traction motors, control systems, and the expertise to make all of it work under brutal railroad conditions. Every ALCO diesel electric that used GE equipment became, in a sense, a classroom for GE. GE learnt what railroads wanted, how they calculated costs, which failures caused the most anger, and how dieselization changed a railroad's entire balance sheet. It saw the sales process up close. It knew the customers, it understood the technology well enough to stop being only a supplier. And unlike ALCO, GE was not a locomotive builder trying to defend one product line. It was an industrial giant with deep electrical knowledge, enormous capital, and the ability to finance big purchases. For railroads making expensive fleet decisions, that mattered. A builder that could help solve the money problem had an advantage before the first locomotive ever arrived. GE also had long relationships across American industry and transportation. It sold equipment, credit, and confidence. So when GE moved from components into complete locomotives, ALCO faced a cruel new reality. It was no longer trying to catch one dominant rival in EMD. It was being squeezed between EMD's standardization and GE's rising power. ALCO did not go down without building better locomotives. Its comeback centered on the 251 engine, and that engine was not just a quick patch for the old 244. It was a more mature design, tested harder, refined more carefully, and built with the lessons ALCO had learnt the expensive way. For railroads that had suffered through earlier problems, the 251 was proof that ALCO could still engineer a serious prime mover. Then came the Century series. These were not museum pieces rolling out of the factory already obsolete. The C420 gave roads a capable 4-axle road switcher. The C628 and C630 brought heavy horsepower for coal, ore and mountain territory. They pulled hard, loaded well, and in the right service, they earned real respect from crews and mechanical departments. Just listen to what ALCO was still capable of producing. But by the time those improvements arrived, the market had changed around them. EMD had spent years filling rosters, training shop forces, stocking parts rooms, and building confidence. A railroad with hundreds of EMD units had a powerful reason to buy more EMD units, even if an ALCO model looked strong on paper. Fleet uniformity had become a business weapon. One supplier meant simpler maintenance, fewer spare parts, easier crew training, and less risk when a locomotive failed far from home. At the same time, railway mergers were reducing the number of buyers. Smaller roads disappeared into larger systems, and the surviving companies made bigger, more cautious purchases. A lost order now hurt more than it had in the 1940s. ALCO had finally built a better answer. The tragedy was that too many customers had already chosen the safe one. In Schenectady, 1969 closed the American chapter. ALCO's name did not vanish. Canadian production, overseas sales, and the 251 engine carried its work forward. But diesel railroading had become a systems business: reliability, standardization, service, and confidence. ALCO helped build the future but could not own it. If you want more industrial stories like this, subscribe to Industrial Empire. Thank you for watching, and comment below. Did ALCO deserve a second chance, or was the post-war market already against it?